Hello and welcome to Disseminate the Computer Science Research Podcast. I'm your host, Jack Wardby. A reminder that if you enjoy the show, please do consider supporting us through Buy Me a Coffee. It really helps us keep making the podcast. It's with my great pleasure that I'm joined today by Madelon Hulsebos, who will be telling us everything we need to know about GitTables, a large-scale corpus of relational tables. So Madelon is a PhD student at the Intelligent Data Engineering, or the Indie Lab, should I say, at the University of Amsterdam. Madelon, welcome to the show.
Hi, Jack. It's a pleasure to be here. Thanks for the invitation.
Fantastic. So let's jump straight in then. So can you maybe tell us a little bit more about yourself and how you became interested in data management or data engineering research?
Yeah, absolutely. So my name is Madelon Hulsebos indeed. And I'm from the Netherlands, actually, so I'm Dutch. And I started actually with a bachelor in policy analysis, very different field, but also exciting, doing lots of simulations on data before I transitioned into computer science and really fell in love with that field. At first, during my master's at TU Delft, it was really when the hype around data science and machine learning really got started. I think this was back in 2016. And I decided to really focus on that. So after I graduated, I became a data scientist. Well, actually, not quite. I first did some research at the MIT Media Lab for half a year or something, which was really a great opportunity where I actually developed Sherlock, which is a machine learning model for semantic type detection in tables. And that's actually where my interest in this field started. But I thought, okay, I want to really make tools that are used in practice. So I thought, okay, what is a good opportunity? I really like data science. So let's see, if I can really do some kind of research job, but then in industry as a data scientist. So I became a data scientist, and then I realized that actually most of my time was spent on building data validation pipelines, data preparation pipelines, and so on. And in the meantime, I really saw my work on semantic type detection actually get a lot of impact in practice as well. And people were very interested in this work. So that pulled me back into research. And that's where I started to focus more on data management research. And I think actually there's so much potential in the intersection of AI and data management. And I think we see the signs of that actually, now since a year or something with the whole generative AI hype, of course. But there's so much potential when you apply this kind of technology to tables and databases in general. So I'm really excited about it and to continue my research career.
Fantastic. That's a great backstory there. That's you also see, I don't know, I've seen it, the shift over the sort of last 5 years, and even in conference proceedings of sort of as ML and AI has started to make its way into sort of data management and all the possible opportunities that are there for this sort of intersection of the two fields, which is great. Cool. So let's talk about GitTables then. So give us the elevator pitch for it. What is it? Why do we need it?
Yeah, so that ties into, of course, the story that I just told. So I think it is really important to unlock the value of the data that resides in databases through machine learning. And one thing that you need to train and use machine learning models is, of course, data. And that is actually what motivated the development of GitTables. So GitTables is a corpus of tables extracted from GitHub, in particular CSV files from GitHub, because you can find basically anything on there. Yeah, so we, of course, now have only a subset of tables extracted because there's a long, pipeline to go through. But GitHub really, I think it stores now 90 million CSV files, which is huge. So our objective is, of course, to get them all out and make this a fruitful resource for machine learning in data management applications, but also data analysis, for example. So huge potential that we probably get into later on.
Yeah, for sure. Kind of a few questions kind of fall out of that from me there. So it's only CSV files. Is it, well, we could maybe touch on this later on maybe, but what about other types of files that are stored in GitHub? Is that something that you're kind of looking at bringing in as well?
For now, I think so. My main focus is now on CSV files, but also because there are so many
Mm,
stored on
mm,
GitHub. Of course, I checked also, for example, like real spreadsheets, Excel files, and so on. But the scale is really smaller.
mm.
And I want to get like a corpus that is as big as possible to really make these machine learning models powerful. So that's why now we focused on CSV files, but you can find anything. And I think that's really, the potential that we show as a starting point, but it really depends on the interest of applications there.
Sure, sure. So yeah, kind of on that then. So how does Git tables compare with what's already out there, or maybe differ with what's already out there?
Yeah, so our problem is that we, as I mentioned before, we were working on this model Sherlock for semantic type detection on tables, basically mapping column to a real world concept. And that actually motivated, well, many people in use cases. So for example, people from Microsoft that wanted to integrate this model into their tools. And one thing we noticed from the feedback is that people were clearly having different data. So that what we see in databases is very different from the data sets that were around and that we use to train Sherlock. This data was actually extracted. So these tables that we trained these models on were actually extracted from the web. So basically web pages and then tables presented on there. But you can imagine that these tables are much smaller and are very, very different from the kinds of tables that we find in databases. So a few aspects that make these data sets very different is one, they are much smaller. So tables on the web are much, much smaller. But two, also the content is very different. So tables in CSV files or in other applications, they're typically very messy and they contain way more numeric data. So I think those are a few of the like selling points of Git tables, let's say, in context of other table corpora. And I think the semantics of what these tables really contain, so the meaning of this data is also very different. And that's also what we show in the paper, for example. Yeah, so an example of that is that the most common attribute in tables is the ID type, as we call it. Well, in web tables, this is really not not one of the most common types around. So I think that clearly demonstrates the difference and complementary value of Git tables in relation to other data sets.
Okay, cool then. So yeah, so obviously when you were going through this process of collecting all of these tables out of GitHub, how did you approach them? What were your design principles you were looking for when you were going about designing Git tables? What was your guiding sort of philosophy with it?
Yeah, we had some very very clear criteria that we had in mind from the observations that we had on other corpora. So one was we needed many tables to fuel machine learning models. So we needed scale. And second, we needed relevant semantics. So the type of data that you find in databases. And we needed kind of coverage. And then we also needed the semantics, as in enrich these tables with metadata that we can use to actually learn machine learning in a supervised way. So we wanted to have kind of annotations on columns to, for example, enable type detection models.
So just on the first principle there, the scale, but you obviously want a lot of this, so it's useful to machine learning models. What is that tipping point? Like, when does it become useful? Like, how much data do you need before these things actually, I guess, become useful?
Yeah, that's a good question. I haven't really run an analysis of that, but what I went with for semantic type detection, for example, is that I wanted to have at least 1,000 columns per type. But it really depends on the application, but also on, for example, now we have all kinds of like pre-trained models, right? So then you might get far with only, a small data set of tables. And I think therefore, with these million tables that we now have with GitTables, we might actually facilitate fine-tuning of pre-trained models as well, which have been trained on way more tables, perhaps from the web. So I think that's a good opportunity as well. But yeah, of course, we are really keen to get most of these tables out of there. But it will be a hard task because GitHub can be really restrictive on the API and the load that it allows.
That's a nice little segue there into the next question. And so how did you actually go about creating this, and walk us through the construction pipeline?
Yeah, so actually it's pretty basic. So we just extract. So our first goal is to extract as many CSV files as possible. And because GitHub has all kinds of rate limit restrictions, we had to segment our queries. And we do so by adding an attribute on the file size. So we only extract files on for a certain keyword. We always need to have a keyword, of course, to search GitHub for CSV files. And then depending on whether a keyword appears in a CSV file, you get the result. But as we also show in the paper, if you look for CSV files with the term ID, you get 60 million CSV files already. And of course, you cannot just extract them all in one go. So I think GitHub only allows you to go through 1,000 items per time per query. So we then segmented our queries based on the file size. So we first extracted, between 50 and 100 kilobytes, for example. So that was the first step. And then, when we have all those CSV files, which takes basically most of the time of the entire construction pipeline, from those CSV files, we then have to parse them to tables. And that sounds pretty straightforward, but these CSV files are so messy and they follow so not the standards of CSV files that you have many comments, for example, on the first few lines, which is not as we intended, right? So we implemented some heuristics to filter such cases out, but this will still be a challenge, an open challenge. And actually, GitTables is used now to also build better CSV parsers. So I'm really excited about that. But yeah, we then parse these CSV files to tables with a basic parser from Pandas. And then we also curate these tables based on whether they have PII data, so personal identifiable information. So for example, if we know that the table contains personal data, then we fake some of these values. So for example, we fake the names or the addresses in a given table. And we also filter out tables that do not come from GitHub repositories with a license. So when we first released GitTables, we were actually, I think we had a slightly bad timing with the release of Copilot. And Copilot was trained on all code in GitHub, also code without permissive licenses, but there was a lot of ethical concern around that, which is rightful, right? I think that's really good that we take these considerations. But we had some ethics review actually that's kind of restricted or kind of informed us to also filter out tables that didn't come from repositories with a proper license. So that reduced the size of the corpus from 1.6 or 7 million to 1 million. And yeah, so that's one one rule that we applied. And then we had our collection of, final tables, let's say. And from there, we also annotated these tables, as I suggested, because we are interested in having column types. And we employed very basic type annotation methods, basically checking the column name, the similarity of the column name with the types in our ontology, so within our interest. And if there's a syntactic match, then we annotated the column name with the type from schema.org or DBpedia. And we also had an embedding-based approach where we embedded the column name and the types, and then just calculated the cosine similarity. And based on that, we informed whether there is a match. So yeah, I think that concluded the construction pipeline.
Nice. So how long did it take end to end to run this? If I just, I don't know, ran the full thing today, like how long are we talking?
Yeah, so it's actually months. It's very hard to get them all out. And this is, so you can only run a few number of queries per hour.
Right, okay.
So based on our segmentation, because our objective is to get as many CSV files out there as possible. So we just have very high number of queries. I'm not sure what the number of queries is in total, but we have so many queries, it just takes months to get them out.
Wow, yeah, it's very topical at the minute. I guess given Elon Musk's recent activity on Twitter, but with rate limits, right? So it's it's at the forefront of everyone's sort of mind at the minute. But that's
in the
really
meantime, I think Microsoft actually bought GitHub in the meantime, further restricting its rate limits. So I think, it will take some time before we get to 10 million tables, for example. But this is clearly our objective.
So it's still running away today. It's still just churning away in the background.
It's currently paused.
Okay.
But I need to resume the extraction pipeline. But there was some issue that we are now under, we're getting mainly the smaller CSV files out of GitHub. So I need to redo the segmentation a little bit, and then we can continue, because we also want to have the larger tables. And although the average number of columns and rows is already way higher than the average number of columns and rows in web tables, for example, so the web-based table corpora, it's already higher, but still there are many more files out in GitHub that are much larger than we now have.
Yeah, on that, so what's the frequency of which new tables enter GitHub as well? Like, I guess that obviously that's growing over time as well. Are you kind of keeping up with that, or is it I don't know how fast new data has been kind of deposited in GitHub?
Yeah, that's a good question. So I think so many things on GitHub change every day. It's very hard to keep track of that. And what we also need to do is figure out how we can get rid of duplication, for example. So one thing that GitHub does is that it doesn't return forks, which is good, but you still might have some copies, across different repositories. So that's something that we need to figure out. But yeah, that's for later work, I guess. And now people just have to deduplicate themselves when they use GitTables.
So this whole pipeline from sort of the pars and the annotations, it's all none of it's manual, right? You never have to go in and say okay, it's all automatic. There's no. How did that go with sort of working out? Okay, these first two lines are just text. We need to get rid of those. That must have been quite an iterative process to sort of finally finish on something that I can just let it run and it figure out all these edge cases, because the state space is huge there.
Yeah. So I went through this iteratively, as you said, just checking out what the errors is, what kind of files couldn't be parsed, and then adjust the parsing configuration based on that, so that we could still maximize the number of CSV files that we could parse. But yeah, eventually this is a fully automated pipeline, so it runs end to end automatically. So that's great. It was definitely an iterative process to come to a full pipeline that we were happy with.
Yeah, I can imagine. Because people do some crazy stuff, right? There's loads of mad stuff out there.
I've seen, this has been quite a while ago actually that we first published this data set, but I've seen very interesting things indeed. I just don't know how some people make CSV files or produce them. It's very hard. But so as I said, I'm just really glad that some people now also use this data set, because we also publish the raw CSV files, and they actually use it to build better CSV parsers. And I think that's really nice, because we need them desperately. And I was actually surprised that I couldn't find a parser that, just could figure out the structure of these CSV files automatically.
It's amazing to have that feedback loop. I mean, it's like the most rewarding thing when you're doing research, right? Is actually people go and use it. It's the best thing about it, right? It makes it all worthwhile.
Absolutely.
For sure.
Yeah.
Just another quick question on the annotation method you use in that kind of step of the pipeline. How computationally intensive is that?
I think so. We really used basic methods that were very fast. So we used, I think, fast text, which is an embedding model that's, well, very efficient. So I don't think that takes up much time, to be honest. The main time-consuming thing is really extracting CSV files from GitHub through the API.
Yeah. Is there a way you can kind of, I don't know, is it a pay per, do you have like a payment scheme where you can pay more and you can get a better rate, or is it all just basically this is all you're getting and this is the rate, or is there?
I think actually that's a good point. I think enterprise users might have a more convenient rate limit, to be honest. But I mean, we're at the university, so
yeah.
I did it from my personal accounts, for example, with my personal token. So no enterprise budgets there.
Yeah, no, you need somebody on the inside in GitHub so they can open up the taps for you so you can get it all out faster. But yeah,
I actually asked this, but they said, well, we also need to, if we want data from GitHub, we also need to go through the API.
Oh, really? Oh man,
yeah.
That sounds quite efficient. Too. But yeah, that's surprising. Cool.
But I think that's good.
Yeah. Cool. Right. So you perform some analysis in that you talk about in your paper of like what you found in kind of the V1 version of GitTable, this 1 million tables. So kind of, what were your findings?
The findings, well, first, I was surprised with the diversity of tables that I found. Indeed, as you said, there might be like CSV files for school projects, but I found also many like database snapshots on, I don't know, NBA players, or also much like more biological data and so on, medical data. So I was surprised by the diversity of the semantic coverage there. What I found that surprised me on the contents of these tables is that despite we expected more numeric data, it is actually, I think, 58% is numeric. And that's something interesting, I think, for future work, to create subsets of data based on, for example, the distribution of like atomic data types like numeric or string data, but also semantic distribution, so that we have domain-specific data sets, for example. But that was something that I found very interesting. Still, it's, the number of numeric columns is larger than we find on tables on the web. But this was an interesting finding. As I mentioned, I think in the introduction, the top type that we found in tables was the ID type, which I think makes a lot of sense. But that was an interesting finding.
Nice. So you've also sort of taken this and then to demonstrate the utility of it and say like how it's better than kind of stuff you can get off like web tables and whatever. You've used it in 3 applications. So can you tell us about these applications and what they were and kind of what the additional value that GitTables delivered was?
Yeah, so we, of course, built GitTables to address a need on semantic column type detection because people needed to retrain their classifiers and because the data wasn't representative and the types weren't relevant. So what we did is use GitTables for semantic type detection. And as you can see in the paper as well, you can use GitTables very well to train a classifier for a given number of semantic types. And we compare it with VisNet. VisNet is a collection basically of all existing corpora. So tables from the web, tables from open data portals and whatnot. And what I found most interesting about this comparison is that we also trained a semantic type detection model on VisNet and then evaluated this on GitTables. And there you see that the performance really drops from 0.77 to 0.66. And I think this illustrated to me that indeed all these existing corpora that we find out there don't really generalize to tables that we cannot easily find on the web. So there's a clear like data distribution gap between these existing corpora and GitTables. So I think this was for me the most interesting takeaway from this experiment, although we of course also show that you can use GitTables to train a classifier from training it on GitTables and evaluating it on GitTables as well. But I think this gap was very interesting to me.
Yeah, for sure. That's fascinating. I mean, it just goes to show you that kind of there was like some degree of sampling bias in the web tables, right? And this sort of like flattens out the distribution. There's less. It's not bias, right? It's not like data bias. I guess it maybe is biases. I'm not sure. I'm not sure on the correct terminology. I know there's sampling bias for sure. But yeah, anyway, it's been a long time since I did statistics and machine learning and all those sorts of things. So yeah.
Yeah, no, I can imagine. Yeah, I mean, I found also very different results across different sets, but I think what always remained constant is this gap in generalizability from models trained on VisNet to GitTables. So I think that really illustrates the complementary value of GitTables, and I think that's pretty cool. And that actually ties into the second application that we considered, which is actually benchmarking. So I think GitTables, you can extract many subsets based on the application need that you have. So you might find very large tables in there. You might find smaller tables. You might find different like atomic data type distributions and just filter based on that. So that's what I'm involved in another project where we do that. Or you might filter down on domains, right? So I think that's cool. But we integrated GitTables in the SAMTAB challenge, which stands for Semantic Table to Knowledge Graph Matching Challenge, where we try to enhance knowledge graphs based on data found in tables. So this is a challenge that runs at IceWig, and there we've been always using like tables from the web, which more easily are linked to knowledge graphs. But what was very interesting, what we found there, is that when you try to do this for GitTables, you don't have this one-on-one match between, for example, column cell values and entities on Wikidata or DBpedia or something like that. So I think what we saw there is that the performance of these like matching based tool systems, the performance really dropped tremendously when we evaluated them on GitTables. And in the second year, actually, when we run the same competition with GitTables, we see that now the systems are actually better able to generalize to GitTables as well. So they don't lean as much on just matching strings to each other, which is very straightforward and obvious for tables on the web.
Nice. Yeah, I mean, it seems like kind of good contribution to the area. Like it's delivering a lot of value on so many different fronts. Like I can see it being very popular for many applications for many years to come. And I guess kind of where do you go next with it now then, and sort of addressing the existing limitations of it to kind of let it deliver more value?
Yeah, so I think for GitTables, what lies ahead for me is to just get all the CSV files, right? So we want to have an even larger corpus. So I think that's the main future work for GitTables, although I really invite people to contribute, for example, or let me know if they have a better parser so that we can redo the parsing, for example. I think I'm interested in creating different subsets of GitTables. Also, as we said, perhaps some domain-specific subsets. But I think there's many interesting potential in the applications of GitTables. So, for example, you can think of SQL recommendation given certain tables, right? What kind of analysis can you do on them? But I think on the data management side, I think you can also inform, for example, query optimizers if you know the semantics of these tables. So I think there are many applications to still explore. And I think GitTables can be a useful resource to do so.
Nice. Yeah. I guess once you've, I mean, here's a question for you. Do you have an estimated deadline? Say we resume the pipeline today. Do you know when you'll get them all? Like, is there like a future date where it's like, I'm going to have it, assuming that you kind of are keeping it with the pace of new data coming in, obviously, like, but is it like, okay, I don't know, 2025, September the 6th, that's the day.
Okay. I think actually I'm a little bit delayed because we actually aim to have them already in 2023. I think we won't make it with the current rate limitations, but I expect I hope to have at least another version of GitTables, much larger one, in 2024, probably near the end.
That's nice. That's the release date to look out for then.
Yeah, this discussion is actually a great motivator to resume the pipeline and get back to it. Yeah.
Get things going again. Awesome. Cool. So I know this is obviously it's obviously had a very big impact so far, and there's people using it to kind of improve the CSV parsers and things like that. So I mean, kind of bigger picture, kind of what more impact do you think your work can have? Yeah, we touched on it a little bit, but like, and also kind of how can people in their day-to-day sort of working lives like leverage the things you found and use GitTables?
Yeah, so I think actually across the entire analysis pipeline, there are so many applications to explore because many of these tasks from, data exploration to data storage, all the way to data analysis, data visualization, and so on, they all operate on tables. And I think that, so many tasks are part of this pipeline that can benefit from learned models over tables. So that's something that I am really trying to push a little bit to start exploring more applications across this pipeline. Also organizing, by the way, a workshop on this at NeurIPS on table representation learning. And I think it's really interesting to see applications such as question answering. And I think that can also be very interesting to try out for GitTables. But yeah, I think there's just huge potential in trying different applications. And for example, data validation is another one that I'm really interested in. So for example, can we predict relevant data validation rules from the contents, right? So if we see different configurations of data validation pipelines for given data sources, then we might be able to infer reasonable rules for new data sources. So I think that's something that I'm interested in as well. And I think actually that would be one of the examples that have major impact in practice as well. And I think actually my research has been really driven by practice. So what actually drove me back into my PhD from being a data scientist is the feedback that I got from people in practice that were using semantic type detection models. And I think there's just much potential given that the entire data landscape is dominated by tables, right? So I think there's just so many practical applications possible if we use this data source right.
I mean, I think it's nice as well that you've been out there in the wild in industry and seen there's a need for it, and then like, okay, I'm going to come and address this. And I think that when you've got that sort of bigger picture view, it makes sort of the day-to-day grind of the PhD so much more sort of, I don't know, tolerable in a way, because like, I'm working towards something that's going to be of use to people, right?
Absolutely. It's a great motivator. And it was really helpful to have done already a little bit of research before I started to inform my proposal, basically, for my PhD research. I think that's been really a good decision there.
Yeah, awesome. How, as a user, how do I go about kind of using GitTables? And like, is it like where's it hosted? How can I go and get the data, basically?
So we currently host this data set on Zenodo, and they will make sure that this data persists over time. It's publicly accessible. They have an API. I'm not sure how stable it is, but it should be very easy to get this data out of Zenodo, actually. We publish it in subsets. So as I expressed, we have these like topics that we use to query GitHub. And we publish the tables per query topic, let's say. You can
Nice.
find it. I'm not sure. So there's some code, but there is also a website like gittables.github.io. And from there, you can basically find the paper, some analysis, some documentation, but also the links to the data set.
Awesome. We'll be sure to link that in the show notes as well, so the interested listener can go and find it and have a play around with it. Cool.
Perfect.
So I kind of on this journey you've been on with GitTables, and what's probably the most interesting thing you've learned while working on it?
I think what was interesting to me was the range of applications that we could serve. So I really started with the intention or the purpose of using this data set for semantic type detection, for table understanding, right? But along the way and during the rest of my PhD, I figured that there are so many other applications that can be fueled by GitTables and learn models over GitTables. And I think that was one of the key lessons, right? So I got really much visibility to all the application potential. For example, the CSV parsing project, which I think really opened my eyes, right? So I think that was pretty cool.
Awesome, yeah. I want some war stories off you now. Then. So I kind of across this journey, like what were the things that you tried that failed? What were the dead ends? What can you kind of, I don't know, to avoid people going down the same kind of wrong path, maybe? What were the war stories?
Yeah, that's a great question. So I think this project I think lasted over 7 to 8 months in total, and during that first month, I think the first 2 weeks, I already discovered the great value of GitHub after a week-long thinking, like, okay, where can we find relevant data? And then I started exploring different data sources. And then I found, okay, we can actually use GitHub. It's like this pot of gold sitting there. But instead of starting to extract all of these tables, we first explored the direction of trying to replicate the semantics in these tables with data from Wikidata. And that's, of course, it made sense back then. Okay, let's synthesize tables that look like tables from GitHub, but aren't. It made sense back in the days. But now I think like, okay, that was like a completely dead thought. And that took actually the most of the time of this project, trying to figure out how we can replicate the tables that we found on GitHub. One way why we did this is because if you try to synthesize these tables, you have the ground truth metadata. So we then could use the kind of structure that we had in Wikidata, for example, to make sure that we know that all the data that we would then put in, like cell values, for example, actually resembled or like were associated with the types. And now we just annotated the tables that we extracted from CSV files on GitHub, which is a bit more noisy. But yeah, that was why we actually took that other direction as well.
So of that 7 to 8 month sort of journey, like, how far through was this? You said like there's the lion's share of the time before you changed, basically.
Yeah, I think.
Wow.
I cannot really remember the exact time spent on that alternative direction, but I think like a couple of months, probably 2 to 3, maybe 4 months that I spent on that, and then started extracting all these tables. Yeah,
it's always hard, right, when you've kind of gone so far down something, you spent so much time, you kind of just want to kind of force that thing to work, but sometimes you just got to roll it back, right, and say, okay, let's go in a different direction. But yeah, it's hard to do that sometimes, for sure.
Yeah.
Cool. Yeah. So obviously you do a lot of other things other than just this Git table. So can you maybe tell the listener a little bit more about the other research you're working on and other things you've got going on?
Yeah, absolutely. So I'm generally interested in learning from tables. And of course, now I've been focusing on table understanding. So for example, semantic type detection. One low-hanging fruit project that we had there, but was actually driven also from feedback from industry, was, okay, how can we adapt these models to custom types? So for example, if we want to have semantic type detection in Power BI, for example, or Excel, then how can we allow users of these tools to add their custom types? So that's something that I'm working on now. But that's, like I said, low-hanging fruit, although very impactful in practice. Another project is, more analysis focused. So in the meantime, we've seen quite some pre-trained models over tables. So really representation learning for tables, for example, for question answering. And it is still very unknown how these models actually work. And I think that's generally the case with many of these, like, representation learning models or generative AI. And I think that's something that is worth exploring as well. So that's what I'm working on as well. And then going forward, I think I will first finish my PhD, hopefully this year. And then I'm very keen on exploring more, more applications of table representation learning.
Fantastic. Yeah, the explainable AI sort of stuff is fascinating, right? I mean, it reminds me of a book I read a while back, the Weapons of Math Destruction book, which I guess is sort of kind of a little bit in that sort of area, but kind of, I don't know if you've ever read it. It's a really good read if you're interested. I'd recommend
thanks.
it.
I will.
Yeah, it's interesting. Yeah, it just tackles the whole sort of like a lot of it's fairness and then explainable AI, but yeah, kind of working out what these black box models are actually doing and being able to kind of give a reason. But yeah, it's cool. But yeah, no. So you're going to finish the PhD, and kind of what's next after that? Are you going to stick around in research, or back to industry, or hybrid role? I don't know. Yeah, what's the dream?
When I started the PhD, I thought, okay, I will become a research scientist in industry, but actually, I will probably stay around in academia. So you will hear from me.
Fantastic. That's great stuff.
Yes, I think so. I think there's just such a potential of representation learning, machine learning over tables in this whole analysis pipeline, for example, that it's too early to quit.
Yeah, fantastic, cool. And I guess going on to this then. So this next question, by the way, is my favorite question. I love hearing people's answers to this question. So it's kind of all about your creative process and how you go about generating ideas and then selecting what things to work on. And then obviously maybe as well knowing when to pull back from an idea like you did with obviously this project. So yeah, tell me all about that. Like, how do you approach this problem?
That's interesting. Yeah, so I don't really have a structured approach to generating ideas. I just take time to think. So what motivates me for research, I love to think and solve problems, find the important questions, to answer. So I think I do have some kind of prioritization approach, which comes down to, okay, what is impactful in practice? What do people really need, right? I think there's a societal aspect to that as well. And so that's also, how I use the feedback that I get from people using the products that I build in practice. And I use that feedback to kind of inform me on the interesting or the hardest challenges that they have. So that's something that inspires me. And then I think, I just take a lot of time to think of how to address a certain idea, because of course, so I started my PhD on the idea, okay, we need data sets. So I was very sure of that. But then, just taking the time to think really well through what the proper data source would be and so on, I think that's worth thinking about very well.
Yeah, nice. It's always like, I think I really like thinking about what impact can it have, what problem am I going to solve for somebody, and having that as kind of a key cornerstone of your thinking is I really like that angle of it. Cool, that's great. So another answer to that question. I love it. I've got a massive collection of them all. It's great to hear about kind of how everyone's different. Everyone has a different answer to that question. Well, yeah. So it's time for the last word now. So, what's the one takeaway you want the listener to get from this podcast today?
I hope that people understand the potential impact of learning over tables, because databases and the whole data landscape is really dominated by tables. And we should stop learning about images and videos, even plain text maybe, and start learning over tables.
Fantastic. Well, let's end it there. Thanks so much, Madelon, for coming on the show. It's been a pleasure to talk to you.
Thank you, Jack.
If the listeners interested to know more about Madelon's work, we'll put the links to everything in the show notes so you can go and find those. And again, if you do enjoy the show, please do consider supporting us through Buy Me a Coffee, and we'll see you all next time for some more awesome computer science research.